Hi, everyone. Thanks for joining us today for our webinar, Business Continuity and Disaster Recovery for Mission Critical Kubernetes Applications with Portworx, Rancher, and CDW. My name is Janet. I am a Senior Product Marketing Manager here at Portworx, and I will let everyone else introduce themselves, starting with Troy.
My name is Troy. I'm the Director of Product Management for Rancher Partners and Ecosystems at SUSE.
I'm Jeremy Wise. I'm a pre-sale solution architect with CDW.
And I'm John Skinner. I am also a pre-sales solution architect at CDW.
Thanks, everybody. So for our agenda today, I'm going to kick things off with an introduction to Business Continuity and Disaster Recovery, or BCDR. Then I will pass things off to Troy, who will talk about why Rancher by SUSE. I'll cover why Portworx by Pure Storage. John will cover services by CDW, and then Jeremy will help us wrap things up with the demo. So let's start with why business continuity and disaster recovery. And I'll start with a little bit of a definition. So anytime we say BCDR, this is what we mean, business continuity and disaster recovery. And really, these are processes that help businesses recover their data and their operations in the event of a disaster. And disaster can mean many different things. So it can include natural disasters, but also can include things like service outages. Sometimes somebody deletes something that they shouldn't have deleted, so human error, or things like ransomware, or something just as simple as like a cluster failure. And if organizations aren't able to recover from these disasters, there can be pretty high ramifications without a BCDR plan in place. And the reason why this is relevant for Kubernetes is something that we've really seen in the market now is that Kubernetes is passing the adoption phase. And this is especially true. And actually what we see is that for those who adopted Kubernetes, they have more mature deployments. So Portworx actually surveyed over 500 Kubernetes experts in the Voice of Kubernetes Experts report. And what we mean by Kubernetes experts is a majority of the people that we surveyed actually had 4 or more years of Kubernetes experience. And when you think about the fact that Kubernetes celebrated its 10-year anniversary this year, these are people who have been with the technology for a very long time. And these experts are running data on Kubernetes already. And from this cohort, we found that nearly all of the respondents, so 97%, are running pretty data-intensive workloads like databases and AI/ML in their cloud-native environments. So what we found is that it's no longer merely a question of, are you adopting Kubernetes, but really it's where are you on your journey? And are you deploying your mission critical applications in your Kubernetes environments to take advantage of, the speed and the scale that these cloud native environments are able to give? So what we found in Portworx is that a lot of our customers are now building these mission critical applications. So, containerized applications started from stateless workloads. They've moved into stateless workload or stateful workloads. And these stateful workloads are evolving from these small Kubernetes test environments to these critical workloads that are critical to businesses. And what we found is that this is true across industries. So some examples from Portworx customers are credit card companies that are using Kubernetes applications to drive faster credit card transactions, or telecommunications providers connecting end mobile users to 5G services. So anytime you're using your phone, whether that's, making a phone call or texting somebody or using any of your data, that is being run by Kubernetes applications. We also see automobile companies like Rivian, who is actually a joint Portworx and SUSE customer, who is using Kubernetes applications to hit their ambitious production goals with their vehicles on the factory floor. And actually, I would love to open this up to Troy and Jeremy to talk a little bit about what they're seeing with their customers.
Well, we do have another automotive customer, Hyundai, that's achieving a 99.5% SLA on the Kubernetes services on Rancher Prime. Again, pointing to the fact that this is becoming a mature technology.
Yeah, and I would also add in there, as you noted, the initial use cases of Kubernetes was in a microservice and a scale-out kind of ephemeral workload or data that is in transient mode. That is no longer the case. We're now putting mission-critical applications in there that, as part of the development cycle, you have to include in the native workflow, business continuity and disaster recovery as part of the how we build this app. has to reflect those compliance requirements and also the design to accommodate for these continuity requirements. So you leverage the features of Kubernetes like auto scale and auto repair, auto repair and heal, and those things are core. The engine's there. We just have to make sure that as part of our the design plan for the application that we're using it with the use case of the business continuity compliance requirements.
Thanks, guys. So yeah, when you think about these mission critical applications that are being built on Kubernetes, extended outages really aren't an option for a lot of organizations. So going back to the 5G services example, if you're making, say, an emergency call from your cell phone, you need to be able to connect to that emergency line. If that doesn't happen because of a service outage or what have you, that's bad for the end user, but also for the telecommunications company, they could face some legal ramifications, regulatory ramifications. So when you think about it in that context, outages are very, very costly. So 54% said their most recent significant outage cost them more than $100,000, and 16% said it cost more than $1 million. So that cost includes downtime, also includes things like potential lost revenue, and productivity loss from IT teams that need to drop pretty much everything to try and bring services back. So what's interesting, though, is that 80% said that their most recent outage could have been prevented with better management processes or configuration. So actually, Jeremy, I would love to ask you, what are some of the challenges that you see people face with BCDR in their production environments?
Exactly. So when we talk to customers about modern applications and the data and how they're handling the architecture, it's not a side conversation. It's core to the topic. The design needs to have that included into it. And so modern applications also have the advantage of they're very agile, they're very quick to deploy and add features, making rapid changes and iterations fast. But the flip side of that is those iterations and changes also impact how the data is replicated, the RPOs and RTOs of the transactions. Changes in the data structure are not easily backed out. That is one of the most complex parts of modern apps, is as you affect the state of the application and its data structure, that blue-green testing is not necessarily something you can just simply flip back. So data and managing the data and the recovery and making those architectural changes, while also dealing with the fact that it has to be enterprise-grade storage. You have to have storage that can handle the I/O, the workloads, and the availability, so that when those changes and those rollbacks or the blue-green testing has to have an affected state change, that you can do them knowing there's an enterprise storage subsystem under them. And so the software bottleneck is really that you can define and design all of these applications, but you have to build natively within the architecture of the BCDR. And then you have to make sure that the application teams are mapping those changes immediately within the design. And the other part is that there are a lot of diverse applications out there. We would love to see all these applications immediately go native, cloud native, high available by scale out architectures. But there are certain components of the applications, either that's not cost effective, or the effort to handle that subcomponent of the total stack of the ecosystem is not going to be effective to retool, and maybe a COTS app is more effective, that we need to handle that data differently. So you have to kind of stitch together that component, knowing that you may have different needs for different data types and data use cases. I/O and also the use case of the data based on performance and latency may also drive, where if you use a replication that's using software for transaction, it may not be able to keep up versus using a more storage traditional chunklet or block replication. It can burst and then catch back up. And so again, it won't impact your production. It won't impact your ability to have transactional speed. Yet be able to catch back up and bring the storage back into a replication compliant state. So all of those things that traditional IT operations have been using for decades has been continuing to bring up into the Kubernetes story and ecosystem with companies like Portworx. And so some of the core components to success is when we talk about the software integration, the software team has to, again, design this integration with the recovery point objectives and the applications based on what the different applications need. Some applications have a very low requirement for RPO. The data is transient. The data is in an ephemeral state. The data can be easily repopulated. Again, those apps are fairly straightforward and simple, but others, either components or subcomponents of the application, those data types are very much different. They may even have state changes within the data as they roll through different versions, and it's a one-way change. And again, those data compliance and workloads, you have to bake into the app as you deploy the changes to the app state. How would you back that out? How can you affect the state of it? And how can you make sure that its affected state moves throughout the app, even in your DR strategy? And those are all complex things you can build and do, but sometimes it's easier to let the storage do what it's supposed to do, create all of those constraints for making sure that they're compliant. Some applications, the workload is that the data in its change is handled within the application, but there are other things that wrap around it, such as you have logs and security events and such that are native and stored in other places that, again, have to move along with the data too. So you might have the transaction, but just as important as the other components of the data. You also have to have a flexibility, because when you talk about DR, there's a lot of moving pieces there. You have things like the networking, its policies, prioritization of the data and how it comes up. Most DR strategies, you're not going to be bringing up everything. You will use a subset of your app. So you need to also work to the fact that the app may have affected features that are turned off or toggled off when you're in a business continuity failover situation. And so you have to deal with all of that and the data components to that, make sure those travel along with it. And of course, automation is critical. All of the things I talked about of working with the development team native within the core application, the different applications and personas of data types and their needs of different types of copies of data, or how we roll them forward or roll back, and meeting compliance. Compliance is really a big driver to this. You can't not be an afterthought. It has to be a native hook, and automation through that CI process, and then testing that is, again, a core to that whole approach to business continuity is part of the core part of the development cycle. So
yeah, let's talk about how Rancher by SUSE fits into all this. Let's talk why you would choose Rancher as a platform on which to build resilient applications, mission critical applications, and where it fits in your business continuity and disaster recovery processes and plans. So many of you will know SUSE, many will know Rancher, but a few quick things about us. SUSE has been a pioneer in commercially supported open source software for many years, 32 years, most notable for our Linux distribution, but more recently for Rancher. We've brought our efforts and expertise to bear on multi-Linux host management, multi-cluster management with Rancher, and in edge computing more recently. Some numbers here. There's over 50,000 teams relying on Rancher to manage their clusters. 50,000 instances of Rancher either running a cluster or running multiple clusters. Our Kubernetes distributions, the actual Kubernetes itself that Rancher can manage, our distros of that, over 10 million downloads of that. We have a solution for transforming virtualization from the traditional virtualized systems to a cloud native or Kubernetes driven virtualization called Harvester. We're seeing a 68% year-over-year growth in the adoption of that. And more recently, in addition to our suite, is something called Application Collection, which is a curated, trustable, verifiable platform for distributing popular open source applications for Kubernetes, Helm charts, and their requisite containers. And we have built a tremendous infrastructure, very similar to what we had developed for SUSE Linux Enterprise. And we're cranking out 800 or more builds a week as we grow that collection of applications, making sure that our customers are up to date. And those efforts have, we're very, very honored to have been selected to be in the leaders category for the Magic Quadrant from Gartner. And we're in there with some giants in the industry too. So we're quite happy about that. Our efforts in cloud native computing and container management have caught the attention of Gartner. Speaking of Gartner, so they say by 2026, which is coming up real soon, that 80% of software engineering organizations will establish platform teams as internal providers of reusable services, components, and tools for application delivery. So why are they doing that? They've been doing that over time. To paraphrase Kelsey Hightower, and I come from the platform as a service space, so this was particularly poignant for me. Everyone wants a platform, they just want to build it themselves. So we have to have a great deal of flexibility in the platform that we build for our developers. So the objective is to enable platform engineers and operations to scale and provide self-service experiences to accelerate code to production. And right now, or in typical situations, admins are so busy enabling developers and responding to developer requests and responding to supporting application development that takes away their bandwidth to modernize and automate, generally improve their infrastructure, and to plan for things like disaster recovery and business continuity. So we want to make a self-service platform that developers can use and make them more autonomous. And we provide that with Rancher Prime. And this is a very flexible platform in that you can substitute components to make it the platform that you want to build. At the bottom is SUSE Linux Micro, which can be a different Linux distribution. On that, we have our Kubernetes distributions. And on top of that, we have SUSE Rancher itself, which is the platform for managing the clusters, and it has numerous features that are helpful to the cloud native workflows. On that, we can add other components either running on Rancher Prime or running under it or running adjacent to it to provide the functionality that you need. For resource usage monitoring, we have SUSE observability that lets you debug applications, see how they run over time, and we're adding features for cost management and sustainability as we go. To accelerate the transformation to cloud native, and this goes back to what I was talking about, moving virtualized infrastructure onto Kubernetes, we have something called Harvester. SUSE virtualization allows you to transition from another virtualized environment to a Kubernetes environment and be able to move your virtual machines there. Most relevant to this webinar is the storage capabilities of Rancher, because it ships with its own storage capabilities, but you can substitute other storage interfaces. In this case, we're talking about Portworx and some of the features that Portworx provides for handling data in a way where you can quickly recover from an outage. Container and network security, we provide something called NewVector, which can scan container images and monitor the traffic between containers and monitor the behavior within a cluster. And as I mentioned before, we want to give developers the tools they need and the building blocks they need in their platform to build their own applications. And in this case, I'm talking about primarily the databases and other tools that we have in application collection, this curated collection of Helm charts and their containers that lets you build your applications. And you can buy this platform in a number of different ways. You can buy just the bottom layer, which is SUSE Kubernetes. You can buy SUSE Rancher Prime, which is the Kubernetes distributions and Rancher itself, or you can buy the whole thing or any of the parts of it with a packaging called SUSE Rancher Enterprise. I like to talk about a product that I am particularly close to, which is the Rancher Prime application collection. And again, this is relevant to the BCDR discussion because we're talking in many cases here, the applications that we publish are the databases that will provide the data plane for the applications that you build. Now, it's really good to have a secure starting point for building those applications. And we would encourage people to use our distributions of these things because we build them all on SUSE Linux Micro, the base container image, I should say. That allows us to update them extremely regularly for transitive dependencies. So each of these builds comes with minimal CVEs, comprehensive security scans. We use Trivy and NuVector as well as ClamAV on them. They're all SALSA level 3 builds. They all have a software bill of materials in SPDX and Cyclone format. And we update them, as I was mentioning earlier, very, very often to make sure there's as few CVEs in that open source application as humanly possible. All of these builds are signed. Now, why would you choose? A lot of this stuff is available for free, obviously. We are an open source company. And something that is worth thinking about if you're building mission critical applications is why you want a partner to support your organization in this and why you want to use something like SUSE Rancher Prime, which is the validated production builds of Rancher. And it's just because we are quite often, in the Kubernetes community, we're working with a very, very fast release cadence, once every 4 months. And there's very limited support for staying on a particular version, which you may be doing, depending on your use case, for a number of years. And so SUSE gives you the ability to stabilize your platform by sticking with a release for longer. And for those releases that you stick to, we will still provide you the patches and security fixes that do come in for upstream while allowing you to stay supported. And that's what it means to have an enterprise-grade platform for mission-critical applications. And I think Janet's going to tell you why it's pragmatic to combine a mission-critical cloud platform with mission-critical storage.
Thanks, Troy. Yeah, I'm going to dive a little bit into why Portworx by Pure Storage, but I will let IDC do most of the talking here. So Portworx has been recognized as a leader in the container data management marketscape with IDC. This is a new category, and Portworx was especially recognized as being a solution for organizations that are running those mission-critical applications in Kubernetes. And for these containerized environments, Portworx offers some of the most options on the market. And the reason why we have partnered with Rancher and SUSE is to be able to provide that container data management platform to their container management platform. So for those organizations that are running those mission critical applications at enterprise scale, what Rancher and Portworx are able to provide together is that optimized storage performance, that enterprise grade BCDR, and then of course, accelerating developer productivity across the map. So to double click a little bit more into what Portworx is and what we do, Portworx provides software-defined storage for container workloads. So as you can see on the bottom of this image here, Portworx is completely infrastructure agnostic, so it can work with any underlying storage, whether that's on-prem, whether that's in the cloud. We do work with Rancher, but also most major Kubernetes distributions. And we also support pretty much any modern application or database. The logos that you see here are just examples, not necessarily a comprehensive list. So Portworx offers highly performant persistent storage for containerized applications. We're able to provide high density workloads that really don't require that additional capacity or suffer performance issues. We also, through automation, are able to help streamline day 2 operations for developers. So reducing a lot of those manual storage tasks you might find yourself doing, like capacity management, for example, is automated via Portworx. From a protection standpoint, Portworx is able to provide data resilience through flexible disaster recovery policies like synchronous and asynchronous DR, but we also provide Kubernetes native backup and restore, including some more enterprise-grade capabilities like ransomware protection. And similar to Rancher, Portworx enables enterprises to build in hybrid and multi-cloud environments, so providing that consistent and centralized management of Kubernetes clusters no matter where they are. We also provide self-service storage access, which helps drive developer productivity. So you're not waiting on IT tickets or anything like that, and developers free up more of their time to do what they do best, which is developing applications. And as far as how these capabilities translate into business outcomes, I'm not going to touch on all of these. I'll just touch on some of the more relevant ones. But through some of that storage automation and self-service access, what this allows platform teams to do is enable their developers to move a lot faster. And we have customers who have been able to move at up to 3 times the speed. So where some of these time savings come into play is the speed in which you're able to deploy in production clusters, but also some of that reduction in operational overhead that you see from the automation that Portworx is able to provide. And from a resiliency standpoint, Portworx provides data protection and disaster recovery for those mission critical applications, providing up to 0 RPO DR. And for some more information on our disaster recovery capabilities, we have synchronous DR, which provides synchronous replication for those critical applications. And essentially what that means is that there's no delta between your primary cluster and your secondary cluster, as long as they're in the same metro region. There's a latency of about 10 milliseconds, but if one cluster goes down, infrastructure teams just need to fail over to that secondary copy, which is more or less the same as the first. So synchronous DR provides that 0 RPO, very, very low RPO for those critical applications. Obviously, that's not necessarily scalable for all applications. So for some of those tier 2, tier 3 applications, we also provide asynchronous DR, which also replicates between 2 clusters, but that replication happens on basically a schedule that you predefine. So here we see RPO 15 minutes. And those clusters don't necessarily need to be within the same metro region because there is obviously a longer wait time between replication. So if your primary cluster goes down, the secondary cluster will only have at most a difference of 15 minutes between the primary and secondary copy. So those are the, I guess, flexible disaster recovery policies that Portworx is able to provide. And now I'll pass things off to John to talk a little bit about CDW services.
Thanks, Janet. At CDW, we offer a breadth of services to help our customers solve problems like the ones we've been talking about today, as well as a breadth of other issues as well. And to kind of narrow in on a few different practices that I think are more relevant to our conversation today, we have our cloud and cloud native group that uses modern technologies and techniques to architect modern application solutions, similar to what we've been talking about today. We have our data and analytics teams that can help consolidate and build data structures to meet BCDR and performance. Our platform engineering teams can design and deliver architecture into modern data centers and ecosystems, both on-prem and in the cloud, or even hybrid solutions. And then we have our talent orchestration team that can enable your team and do trainings and staff augmentation or anything that you require to, beef your bench up for whatever projects it is that you have. And then our software engineering team can help re-architect software that you may have in-house today, or re-platform, or maybe take an idea that you have that you simply don't have the bench to do today and help design and architect that. These are the types of services that we offer our customers.
Okay, thanks, John. Now we're going to move to the fun part. We're going to talk about the demo. And instead of just doing a simple walkthrough demo and selling a bunch of command lines, I actually like to talk to you as if you were the customer, and this is the use case in a story that you have. The story would be a customer, obviously there are lots of different ways to approach business continuity and disaster recovery. I'm going to tell it through the story of a customer who has multiple locations. They're looking at the fact that they have business mission critical apps. They've moved to the point now of adopting into the Kubernetes ecosystem using Rancher. They need to bring into that ecosystem the storage component along the side of it. They're moving the actual data structure now into this Kubernetes ecosystem, but they have compliance requirements. They're publicly traded. They have multiple locations. They're swimming in the technical debt of traditional data center architectures and the overhead for that, and they want to streamline, how do I bring on a new location? a new office, a new store. And so I drove through the design of a customer here that has like 5 different store locations or office locations. And their need is, how do I design and build business continuity for different use cases of different apps? Some applications are more modern and they do things within the code of the application, or the data is ephemeral. But then we have this whole other set of applications we're talking about today where I have to deal with rollbacks. I have to deal with compliance. There's ransomware concerns that I need to make sure we cover the capability, and just physical disasters like Troy called out, where hurricanes. We just had a bunch of those go through. All those other situations that you just need to have that plan in place, because like Janet called out, these things are a sunk cost to a company, but they're so critical because the other side of that coin is, when it happens, we're losing at least $100,000 on average, you said, and many times it's much higher than that, because it's both soft costs and hard costs, and also costs related to lost revenue and other things that drive into that factor. So this is the design here, that is a little diagram put together that talks about these 5 different locations. And SUSE has a supervisor cluster. The supervisor cluster is your control plane that can initiate the changes to all of the different workload clusters. And you may have workload cluster specific tasks. Some may need AI workloads and have GPUs. Some may need storage and high available storage and high performance storage difference. And so we have a diagram here where we have your traditional application in a modern framework. You've got your dev cluster. The teams develop an application, they deploy it to dev. It gets promoted into production. Its data structure is then built and structured there, and it needs to have business continuity. Some of those workloads may be live and continuous, where you'll have live workloads in your DR. Some, like these, it is more cost effective to let the storage do the replication and meet all of the compliance that we have to have. And we focus on the application, or the application's a COTS app, or that subcomponent is a COTS app. You can choose and pick how you want to host it. Because in the DR, as you see in this diagram, we have the supervisor cluster. And this is kind of a central DR. All of your sites are plugged into a common structure. You're gaining commonality of assets to build it. You're gaining commonality of run environments, playbooks. You can just build a new environment very quickly, or tear one down if a site changes or goes away. And so you're centralizing all of your business continuity, talent, skills, the policies, security, compliance, and code. All of those things are then brought together in a central DR strategy architecture and done through a code automation. We talked about automation being one of those key pillars. And in this case, as you see there in the gray, your storage is left as just enough in the environment to allow for business replication. So as your IO is in high performance and doing a lot of IO and meeting the responsiveness to the app in your production sites, your DR and the replication to the DR can be scaled to be just what it takes to make sure it's high available, no single point of failure, but is just taking the consumed data change rates as you deal with your RPO. Different sites could have different RPO, different apps, the actual replications done within the namespace. So you can choose based on the application as you develop the app. Part of your life cycle of developing that app is defining it in the code as to what your RPOs need to be. And that moves along with it as it defines the replication to your DR. And then when a site goes down or has to have remediation done, or as a disaster happens, or ransomware hits, when you hit that big red button, so to speak, all you're doing is going into the supervisor cluster at the DR and literally just taking the licenses, taking the deployment structure of Rancher workload cluster, and bringing them into a hot state in your DR. And so that's the strategy that we're building here. So let's go ahead and go to the next slide. And I'm just going to talk through, when you build Portworx and in Rancher here, there's a lot of CLI stuff, and I don't want to click through a lot of CLI here, but I want to talk to the fact of, you build the cluster, you build the storage, you add the licensing, you link the relationship between the remote and DR. And we have an application here like Postgres or Cassandra. Postgres may not need or have the ability to do replication itself with the application. So we're going to simply do a command here that says, we've got the 2 clusters ready to go. How hard is it to build this up and build the business continuity? We simply take a look at the cluster pairing. They're licensed together, they're paired together, and we can define them as async or synchronous. You choose, and you can choose how you want that data connection to go. And most of that's driven by your latency and the link between the sites. But most customers will do async no matter what. So now we essentially just pair the cluster objects together, which is the 2 Portworx clusters. They're simply just workload clusters that are storage rich, whichever storage you have, DAS, SAN, iSCSI, NVMe, you do you, all right? And then you can then build this migration schedule. And that just simply says, I have a migration schedule every 2 hours, every 4 hours, once a week. And then I bind that to the function of the application. And then in this case, we have a set of applications in this Portworx store. And there's where you can then say in this demo here that they simply just show that transactional replication is done. In this case, this is done synchronously, but you could easily say at a normalization point, we normalize the data with hot backup state within the Postgres or Oracle or EDB, whatever it is. And when the backup's in a hot backup state, then we essentially create that replication. And now we're watching the fact of we've put the data there, and now we've seen that the replication is transferring from the one site to the other, and you can see the resource utilization. So it's enterprise storage. It gives you the visibility both into the sync state, simple replication. It handles all of the backend components to it here. And then you as an administrator can come in here, or as an application developer can come in here and say, I'm rolling out a new app. The application's into a backup state. Let's get it copied over there. And now we see there the migration is complete. I'm in the ability to now do my blue-green testing or fail over to my DR. All the VMs are shut down. I know I'm going to be going down in 2 hours because we have a situation in the data center. Make sure that they're all into a transactional, healthy state, and then see it fail over. And now you can see that the application has now been moved into a read-write mode at your DR. And now you can see, again, all of the Portworx pods are up and working, and your cluster IP is available. And now your app essentially can come back online, and your developers can then trigger the app, the layer of the tier to start working. So we then have the store back up and working. And that's all traditional stuff within business continuity and disaster recovery. But bring this back to the story of why does this matter to you? Because as you are a code developer, or as you are an operations person, whoever you are in the personality in this call, this stuff matters to you. You need to do BCDR. It's a sunk cost. Nobody cares about disaster recovery until you need it. So you have to bake it into the modern app developer teams or to how they develop it. You need to bake it into your operations team. And let's leverage that centralization of we create the workload clusters and then only bring them up when we need to. And in this example, I just ran some quick numbers here where we essentially ran through that example, store locations as that diagram here, and we saved about 25%. Now I know operations costs are a little bit soft and fungible. So it's some of it is licensing because the licenses are transferred, because the licenses you're not actually running the workloads or just significantly reduced workload. But the real savings also is the fact that you've built all of the centralized policy management, security controls, RBAC, data access, data recovery workflows. All of that is essentially centralized, and those 5 sites can leverage this ecosystem they've built in this business continuity DR strategy. So that's what I got. And one other thing to show here is, I didn't have it up on my demo, is Portworx, obviously, for those personas, operations, help desk, and other resources who want to be able to say, how is my Portworx storage? Obviously, we have a dashboard we have built in here. As part of the operator, most of the interaction is with command line, hence why I just watched the video there. And it's a fairly simple set of tasks. But there are use cases for using a dashboard here, personas related to the help desk and such, junior admins and things, where this is a really good tool for them to just drill into the storage. Do we have a disk offline? Do we have a storage node offline? Where is the health state of replication? And what nodes are in replication right now? And all of that can again be seen through the dashboard we have here that Portworx has built and into the Rancher system as a plugin. So Janet.
Thank you, Jeremy. So if you want some more information on how to engage with Portworx, Rancher, and or CDW, we have all of our websites linked out here. If you're looking for a place to engage with us in person, we do actually have a couple, engagements available for you. So the first being our Portworx Rancher Stampedes. These are live technical workshops where you can get hands-on keyboard, interact directly with Rancher and with Portworx. We have our first couple of dates already announced. So Dallas will be on this November 7th and Salt Lake City on November 21st. And Dallas does have a live registration page, which is linked out here. Salt Lake City to come soon. And we do also have future workshops planned both in California and Colorado. So keep an eye out for those. We will be expanding those throughout the year, but we're starting in the West and Central region to start. We will also be at KubeCon Salt Lake City, which is also in November, November 12 to 14. And Portworx will be live at the SUSE booth on Wednesday from 1 to 1:45. This will also be a time to engage with our technical experts and get some live demos at the SUSE booth. And SUSE will also be at Portworx's booth giving a couple presentations, and keep an eye out for when those will be announced. And that wraps up our webinar for today. Thank you so much for joining us.